right, we are going to wrap up this review of lines section 8.1 with some application problems. So, number one, let P of n equal 480n minus 12,000 give the profit in dollars when n computers are sold. So the first thing I want you to notice is this is a familiar form. P of n is like an f of x is like the output is like the y equals, and what we have here is like the input. N is what we often use as an x, so the input or the independent variable here, instead of being an x, is n. And we have it solved for y. So y equals, we have it in the form, my whole point here, y equals mx plus b. So I want you to kind of make that connection. Obviously the input, so this is, let's just say like, or in that same form of y equals mx plus b. So as we're looking at part A, it says find and interpret the slope. Well, the slope is, in this case, 480. So our slope here is 480. Now we want to interpret that slope. So we want to think of slope for interpretation's sake. If it's not a ratio, put it over 1. And then what you want to do is you want to tack on the labels that kind of give a practical sense of what this change in y over change in x is. So if you think about the y, or the output label in this case, the output label is, this is $480 dollars in terms of what we're looking at for the profit. That's what the output is giving us, the profit in dollars. And then the input per 1, and that is our n, is the input variable, and this is our number of computers that are sold. So it's really just looking at what the output per the input variable mean in practical terms of the problem. And that helps us to reveal what the interpretation would be. Especially if you remember the fraction bar, we can kind of read that as that per idea. So this is telling us that there's an increase of profit of $480 per every one computer sold. So we have a profit of $480 per every one computer, or just computer, sold. So I kind of ran out of room there, but I think you get the idea. All right. Part B, find and interpret the vertical or y-intercept. So make sure you're kind of comfortable seeing that written instead of as a y-intercept, as a vertical intercept. Of course, the vertical axis is the y-axis, so that is the b, and in this case, the b is minus 12,000. So what we want to think about is what that looks like as an intercept. I was always a proponent of thinking of it as an ordered pair. So when you think about the vertical intercept, that was always where you would sub in 0 for x and solve for y, if you kind of thought about it that way. And at this point, what we want to incorporate, though, is the function notation. So we're looking at p of 0 equaling, and we've identified that that y-intercept is negative 12,000. So this is the vertical intercept. This is kind of writing it also as an ordered pair in function notation. But this helps us make that interpretation. So when we think of it as an ordered pair, the input there, the 0, that is saying the n value, so 0 computers in this case being sold, and then the output here is the profit. So this is telling us our profit, and that's going to sound a little weird, we're going to replace that with a different vocabulary, is negative 12,000. So if we pull this together for our interpretation, this is going to tell us that if there are no computers sold, so if nothing sells, if no computers are sold, they have a loss. There's no profit. They didn't even break even. There's a loss of $12,000. Okay, that's the negative reflecting that loss. I don't need to say a loss of negative 12,000 because when I say loss, that is incorporating the fact that it was negative. So a loss of $12,000. All right, find and interpret the horizontal or the x-intercept. So let's think about what the horizontal, or what's typically the x here, it's like the n-intercept. So let's think about what that would look like. So before now, we would say, oh, well, that's where I sub in 0 for y, and I figure out what the input, or the x value here, the n value would be. So when we think about that, this one, I can't just read off the equation. There's no number up there that immediately is the x-intercept like we have that for the y. So here I have to do a little solving. So I need to sub in 0 for the whole output, and then I'm going to need to solve for the input. So I have 480n minus 12,000. And so as I solve here, I just have a little linear equation. So let's just go ahead and add our 12,000 here over to the left-hand side. And that's going to give me 12,000 equals 480n. And then just dividing both sides by 480, we are going to get, if we plug that into our calculator, that comes out to be n equals 25. All right, so we just found, if we wanted to kind of put that as an ordered pair, or more specifically, let's use our function notation, we just found that p of 25 is equal to 0. So that's writing it with our function notation. So interpreting, again, anytime you have an ordered pair, whether it's an x-intercept, a y-intercept, or any other ordered pair, you just want to think about what each the x and the input and the output variables, what they represent. So this is telling me that if there are 25 computers sold, the profit is $0. So how we would probably phrase that might be a little bit different. That's what's called the break-even point. We're not really making money yet, but we're not losing money either. So instead of saying when 25 computers are sold, the profit is $0, we might rephrase that and just say it like this. The break-even point, that's what they would refer to this as, is 25 computers. So that's when we're breaking even. We're not losing money and we are not making money yet either, but that's when we are breaking even. All right, we'll come back and look at the last application example in the next one.